Hey folks, thanks for stopping by. My name is Richard and I'm an applied scientist at Alexa. Today I'm excited to share some new research that my team and I have been working on over the last couple of months. In our research, we look at how we can condition the predictions of a language model on both text data as well as associated contextual information. Especially within the context of ASR, it makes sense that we would want to condition the predictions of a language model on the date and time that an utterance was spoken. For example, let's take an utterance like Alexa, look up cookie recipes for. If this utterance is spoken, say, on December 23rd, then the word that is most likely to follow this utterance might be something like Christmas, but it definitely isn't something like summer. Guided by this hypothesis, my team and I collected over 9 million anonymized transcribed utterances that contained the timestamp for when each utterance was spoken. The next question we had to tackle was how do we represent the daytime information? We proposed two methods. The first is to learn embeddings that represent the month of the year, week of the year, day of the week, and hour that an utterance was spoken. We can also directly convert the same information into an 8-dimensional feature vector, which is defined as you see here on the left. There are two mechanisms that folks have historically used to train a language model on both text data and non-linguistic data. The first is to simply concatenate the non-linguistic context to the word embeddings. A more recent method was proposed by Aaron Yage and Mary Ostendorf, who suggest actually adapting the weight matrix used in an RNN model to a given contextual input. In our work, we introduce an attention mechanism that augments both the concatenation-based and factorization-based approaches to condition a neural LM on context. The attention mechanism that we propose builds up a dynamic representation of the context over the course of processing an utterance. The resulting embedding can be used as an additional input to either the concatenation-based or factorization-based models. The main idea is that as you process an utterance, certain contextual information can be more important than other information. So for instance, if you have an utterance like turn alarm off, you want to condition the predictions of your language model more on the fact that the utterance was spoken at 6 a.m. rather than that the utterance was spoken in December. Moving on to the results, here we show the results of our language models. The first language model is a model that does not ingest any contextual information whatsoever. The second model is a baseline model where we prepend contextual information to the text input. These bottom two rows are the models that use our attention mechanism. We report results in relative perplexity compared to this first default model up here. We also conduct some analysis in order to answer a couple of questions of interest. First, we investigate to what extent the improvement in perplexity and word error rate of the models that ingest context can be attributed to the signal contained in the context versus just the fact that these models contain more parameters. To answer this question, we retrain each of our models but randomly shuffle the context that we feed into these models. Sure enough, as you can see in this table, shuffling the context substantially impacts the accuracy of all the models. Next, we also visualize how the probability of an utterance changes as we vary the datetime associated with that utterance. Here you see how the probability of the word snooze changes as we vary the hour of day information. And as you expect, you see the biggest bump here around 5 and 6 a.m. Finally, we can also visualize the attention weights of the attention mechanism as we process an utterance. Thank you so much for tuning in, and ping me if you have any questions. Thanks.